And welcome to Stereopsis, 3D shape reconstruction system using a stereo pair of images. Once selected, the image is automatically calibrated. You can see green green crosses that are reprojected points, and they lie inside of red circles, which were automatically detected for calibration, which means that calibration was successful. Red, green and blue lines represent X, Y and Z axis of world coordinate system, and blue dot is the optical center. On the right side in world coordinate system, you can see camera frame of references reconstructed from calibration and rays shooted from optical centers through the centers of detected circles. The intersection of rays is computed using a method proposed in Truc and Very book. And if we redraw without those lines, you can see the blue dots, the reconstructed points, and the red dots, the ground truth. And the average error is just 4 millimeters. In epipolar lines mode, clicking on one image will draw the corresponding epipolar line on second image, and vice versa. And you can clearly see that the point we selected on bottom or right image has a correspondence on this epipolar line in left image. If we click multiple times, we will get the idea where are the epipoles. For example, for left image, epipole is on right side. And this is consistent with values we retrieved from by computation, that it's very far on right, x-axis is pointing right, and y-axis is pointing up from bottom left corner. And at height, that is lying within the height of the image. The resolution of image is 4K over 3K pixels. And for left image, for right image, the epipole is somewhere far to the left and up. And this is consistent with almost parallel epipolar lines pointing top left direction. The fundamental matrix used for these computations was found experimentally, meaning that corresponding pairs of circles that were also used for calibration are used to build over-constrained system of linear equation to solve for fundamental matrix. But since we calibrated both of the images, we can compute the fundamental matrix in theoretical way by computing first essential matrix, knowing the translation of camera, translation and rotation of camera, and calibration matrices. And you can see this here. The angles between frame of references of our cameras, and we can see that it was significantly rotated over y-axis, over green axis, which is consistent with what we see here. The translation was about 8 centimeters along x and 2.5 along z-axis. The essential matrix, fundamental matrix retrieved in experimental way and computed theoretically. Average disparity was 143 pixels. So if we now try to draw epipolar lines, you can see that they have slightly different angle for left image, and this is consistent with new coordinates of epipole we found. You can see that it's still far on right, but at lower height. Whilst for left image, they are almost the same, and this is also consistent with values of epipole coordinates that are same up to the scale is factor 2 to 3. Let's clean up this mess by pressing enter to reload the images and switch to triangulation mode. In this mode I select points in one image and then same points in second image. He can't select exact points, so we'll choose approximately and click triangulate to reconstruct the shape. And we can see that it was properly reconstructed. It surrounds our calibration set of calibration points, not very accurately because I was choosing just approximately. If we zoom in a bit, and try to reconstruct, for example, vertical axis, these triangulation lines, we can see that it matches y-axis very well, and points lie on the intersection of rays shooted from optical center through the corresponding points I selected. I would like to demonstrate another thing with other set of images. Here, bottom image, right image was taken 4.9 centimeters to the right with respect to the left image, and we can see that it was properly first we recalculate without triangulation lines. We see that reconstruction was less accurate now. Average error is 22 millimeters, and translation vector was properly reconstructed from calibration. It's indeed 4.7 centimeters, so no shift along vertical axis and slight approach along Z, and no rotation with respect to each other of camera frame of references. You can also see that there are 2 points in wrong place. This is caused by numerical instability of the method proposed in Truk and Very book that involves cross product between the rays, and if they indeed are passing by very close, like almost intersect, then the cross product will have some random value, and this will result in wrong result of solving corresponding system of linear equations that contains this cross product. And that's it. Thank you for your attention.